pi there. Solve for the value of x by expressing it in terms of pi in e raised to pi raised to x equals pi raised to e raised to x. So at first glance, this seems quite tricky and hard, but you'll see later on that it is just simple, since the only key thing out here is to constantly apply the natural logarithm as well as some of the properties of logarithm. So before we start, feel free to pause the video so that you may try this first on your own given that hint. Okay, good. So let us start. To solve this, we first apply the natural logarithm on this equation out here. So we'll have ln of e raised to pi raised to x equals ln of pi raised to e raised to x. So don't be confused by raised to, so just refer to these two out here. And then from here, we apply a property of logarithms, and that is, if we have log of a raised to b, then we can actually move the exponent b out here of a outside of the logarithm. So we will end up with b times the log of a. So we apply this to our given, or that is, we move this one outside and this one outside. So we'll have here pi raised to x times ln of e equals e raised to x times ln of pi. And take note that ln of e out here is equal to 1. So that one is trivial, since ln is just a special logarithm with the base e. So log of e to the base e just equal to 1. So as simple as that. So we'll have pi raised to x equals e raised to x times ln of pi. And what do we do next? Well, we just simply apply the natural logarithm out here again. So we'll have here ln of pi raised to x equals ln of e raised to x times ln of pi. Take note that for this left-hand side of the equation, we just again apply this property mentioned earlier. So we just move x out here, so we'll have x times ln of pi, and then for the right hand side, we apply another property of logarithms, and that is, given log of a times b, or log of ab, this is just equal to log of a plus log of b. So if we have a product out here, we can express it in terms of the sum of that two. Applying this to our given, we split this two by sum. So we'll have here ln of e raised to x plus ln of pi. And then take note that for this one, we can apply the first property we learned out here. So we just move x out here and we'll end up with x times ln of pi equals x times ln of e plus ln of pi. And again, ln of e is just equal to 1. So that's trivial. And then just to simplify things, we move x to the left side out here. So we'll end up with x times ln of pi minus x equals ln of pi. And then from here, we are close to what we want. What we do is we just factor x outside of this one. So we'll have x times ln of pi minus 1 equals ln of pi. Since we want to obtain the value of x, we need to isolate it in one side. And to do that, we divide ln of pi minus 1 both sides so that this one would cancel out. And we'll be left with x equals ln of pi over ln of pi minus 1. And is this what we want? Well, yes, this is what we want, since we have expressed x in terms of pi alone. We have ln out here, but ln of pi is still in terms of pi. So yeah, that answers our problem. So we conclude that the final answer for this problem is just x equals ln of pi over ln of pi minus 1. That finishes our solution. So yeah, I hope you got this problem correctly. Again, the key is just to apply natural logarithm twice to be exact, and then apply certain properties of logarithm. This out here and this out here. So that is how to answer this one, and if you want to take a screenshot of this one, you may do so. So we have this out here. So a pretty nice solution, well written. I hope it's well written in your end on the answer for this problem. So yeah, that is it. I hope you enjoyed and learned a lot from this one. Feel free to comment down below if you have any suggestions, recommendations, as well as alternative solutions for this problem out here. So that's it, and that is all for this how to solve video.